the four container concepts in AWS. So we've got subnet, VPC, AZ, and region, and how the four relate to one another. In 2020, a helpful blog post tells us about deployment models for the AWS network firewall. To apply traffic filtering logic provided by AWS Network Firewall, you must route traffic symmetrically to the AWS Network Firewall endpoint. This is a break from previous firewalls. We simply armoured our vulnerable ENI in a protected SG. We armoured our subnet in a NACL and our web server within a WACL, but there was no talk of how to route traffic to these things. However, we must route traffic to our AWS Network Firewall. IP addresses are very helpful for routing. We assign IP addresses to EC2 instances so that we can route traffic to them. Well, we're not using IP addresses here. Question for later, why? Instead, we're using endpoints. What on earth is an endpoint? For students of computing, endpoint is a term from hell. To those uninitiated, explanations of this term appear relaxed and cool, saying it's merely the end of a communication channel. And yet it's obvious that its use is constrained to certain contexts and certain technologies. So it is annoying when people are really relaxed in saying it's just an endpoint. A trivial answer. Suppose I was at a bar, slid over a napkin to someone and asked them to write down the endpoint they were using. How will I know what they've written down is an endpoint? I'm talking about tangible things we can point to. This is just a basic question. I'm not talking about anything complicated here. What do they slide over on the napkin such that I can say, thank you, you have written down an endpoint? Or, no, I need you to write down an endpoint. What do they draw? First, let's consider some napkins that do depict endpoints. Here's our first napkin. Take a look at that. A second napkin. US East 2, that's Oregon. Have you ever been to Oregon? They get the number 2 there, Oregon. This says rds.useast2.api, and then there's another dot, and then it says AWS. So A, W, and S. There's no Amazon. 4 parts. We've got the word, or the letters A, P, and I as one of the 4 parts. A third napkin. This is slightly different. I've put in this sort of orange colour. This term, we haven't seen that before, or in the previous example, it's Amazon AWS. Again, US East 2 before Amazon AWS. We've got .com at the end, but there's no API here. And it says RDS-FIPS. A third napkin. networkfirewall.useast2.amazonors.com. Another napkin. Network Firewall FIPS. So above we had network-firewall, now Network Firewall FIPS, FIPS, US East 2, the East now, AmazonAWS.com, and US East 2 is Ohio, not Oregon, Ohio. Another napkin, SQS.useast2, which is Ohio, .amazonors.com. No mention of API, no mention of FIPS, it's just SQS.useast2. SQS.useast2, not SQS-FIPS. SQS.EU West 3.amazonors.com. So the region, then Amazonors, US West 3.amazonors.com. And another napkin, SQS.US West 3, EU West 3.amazonors.com. What is EU West 3? So some napkins are from this source, others involving SQS are from here. And you can see there's a link to the general user guide of Amazon. So it's not a user guide for a specific product like SQS. They do have just it's called the general user guide. You can see in the bottom left corner of my screen the URL and another URL here from RDS, the user guide. Some of the napkins show legacy endpoints. What do all the napkins have in common? Well, characters are used, such as numbers, letters, and hyphens, or dashes. There are recognizable units, such as US East 1, which allows us to infer that the string of characters has been broken up into segments by the periods. I mean, the periods are not randomly placed, are they? You've seen com before, short for commercial, and it appears in many URLs, such as Amazon.com. You could type that into your browser. That's a uniform resource locator. So you receive back the scribbled napkin from the person at the bar. I clear things up. Apologies, I think you misheard me. I asked you to write down an endpoint. I didn't ask for a uniform resource locator. As it turns out, an endpoint is a URL. AWS write, to connect programmatically to an AWS service, you use an endpoint. An endpoint is the URL of the entry point for an AWS web service. The AWS SDKs and the AWS command line interface automatically use the default endpoint for each service in an AWS region. Okay, so they do use endpoints. If you've used the CLI, you've used an endpoint behind the scenes. But you can specify alternate endpoints for your API requests. You don't have to use the default endpoint that gets used. The following question is raised. Why use the term endpoint at all? It seems that we could simply use the term URL. More people are familiar with the term URL than with the term endpoint, since most people use web browsers and web browsers use URLs. URLs are a special species of unique resource indicators. So URIs. And URLs, uniform, I do think it's for uniform in URL. Uniform resource locators, they were introduced in 1994 by Tim Berners-Lee. And you can see an RFC on that. See the link there. There was a URI working group, the Unique Resource Indicator working group. URLs have an authority component, a path component, and perhaps a query component. There may be a subdomain such as www, which sits within a domain, like Amazon, which is part of a larger domain, .co, and you might have .co.uk. Again, the UK is larger than co. Note that www.amazon.co.uk is not a URL. A URL must include a protocol at the beginning. Here is a URL involving the domain that we just mentioned. Let's take a look at this. So we've got HTTPS and then : //. That's called the schema. Then we have www.amazon.co.uk // This is a book on Amazon, King's-English Essential Guide written /DP / and then a code /ref equals SR110 ? CRID equals. So some important characters to draw your attention to here are the question mark, which means we're beginning the query string, and the ampersand. So here it says keywords equals. There's lots of these name and then equals. So look, you can see it says keywords equals the King English. And you can, so this looks like someone has typed in on Amazon the King's English. Of course, King's has an apostrophe before the S, so in this URL it becomes king %27 S. So %27 must be used to represent an apostrophe. and we use this plus character to join up all the terms. So we've got keywords equals, we've got QID equals. Then maybe that's an ID for the query. Query ID 16658628338. Ampersand QU equals, and then we have another code. Okay. Let's see, this is all just letters, uppercase letters, lowercase letters, and a 6, a few numbers, continuing along, and then we get %3D. Maybe that's a similar code to %27 here, which was for the apostrophe. So %3D, %3D again, and then an ampersand. So if you haven't noticed, the ampersand is the large separator that operates at the high level. S prefix equals. So how many have we got? Parameters have we got? We've got ref equals SR110. That's kind of a special parameter because it's before the question mark. We have one parameter after the question mark, CRID. A second parameter, keywords. A third parameter, QID. A fourth parameter, S prefix. And that's it. So 4 parameters here. So all of this stuff with the such and such equals and all these identifiers, they can be packed in after the /. So we have the .co.uk ending, then a /, another /. So we've got 1, 2, 3, about 3 segments. The final segment is the one with all these parameters in. 6 years after Tim Berners-Lee proposed URLs in 1994, somebody called Roy Fielding completed his PhD dissertation. Fielding completed the thesis at University of California, Irvine, and the title was Architectural Styles and the Design of Network-Based Software Architectures. In this thesis published in the year 2000, the word endpoint is never used. However, it sets out a variety of architectural styles for the web. One of them has become quite famous. It's known as Representational State Transfer, or REST, the RE for representational. We've already seen that AWS security groups are stateful, and we informally explained that this means that they remember traffic which is passed in one direction, allowing response traffic without an explicit rule. That's what it is to be stateful. The paper cannot be explained here, Roy Fielding's thesis. But notice how Roy Fielding is concerned with how things like URLs should work. He writes, REST components communicate by transferring a representation of a resource in a format matching one of an evolving set of standard data types. And that format can be selected dynamically based on the capabilities or desires of the recipient and the nature of the resource as well. That's Roy Fielding speaking. RFC 3340. I believe that the earliest mention of the word endpoint is in an RFC published in the Network Working Group. The authors of RFC 3340 are Marshall, Rose, Klein and Crocker. RFC 3340 is published in July of 2002, 2 years after Roy Fielding publishes his thesis. Rose is also a graduate of Irvine, like Fielding, suggesting that his use of the rather generic word endpoint has the pertinent sense. In fact, RFC 2240, Rose, Klein and Crocker, acknowledges the influence of a 1998 paper by Berners-Lee, Mainster and Roy Fielding. But again, this 1998 paper does not use the term endpoint. So that's RFC 2240, which is influencing a paper, is acknowledging the influence of a paper by Fielding and Berners-Lee. Back to 3340. RFC 3340 by Marshall, Rose, Klein and Crocker. Remember those names. It's describing a message relaying service. Recall that it is 2002 when we get RFC 3340. In just 2 years, AWS will announce that they are beta testing and using internally at least the Amazon Simple Queue service. That's 2004. Rose et al. Are describing an extensible asynchronous message relaying service for application layer programs. So in 2002, we're talking about the application layer and endpoints. We haven't said the term API yet, or used that term yet. Marshall Rose and David Crocker were based in California, and Graham Klein in Reading in the UK. Their messaging service is called Apex. They write, Apex, at its core, provides a best effort datagram service. Each datagram, simply termed data, is originated and received by Apex endpoints, applications that dynamically attach to the Apex relaying mesh. That's RFC 3340. For people who do not understand what an endpoint is, answers like the following on forums are really annoying. Simply put, an endpoint is one end of a communication channel. Well, that's annoying because that's obvious. I could have guessed that an endpoint is an end to something. This sort of answer is simply not precise enough. So, you're in the bar and you ask your friend to write down an endpoint on a napkin. They slide the following napkin back. Something like this. The above napkin is referred to as an endpoint. Okay. So in the general user guide, we have a list of service endpoints. This general user guide is provided by AWS. So it says most Amazon Web Services offer a regional endpoint that you can use to make your requests. The general syntax of a regional endpoint is as follows. So we'd have the service code, like SQS or just RDS or DynamoDB, the service code. Then the region code, like uswest2.amazonors.com. And before the service code, we need the protocol with that double slash. So with the napkin above, there's a protocol at the beginning, which is HTTPS. This shows that sometimes people will list endpoints without the protocol. See the earlier napkins. And sometimes with the protocol. Okay, that's fine. Okay, sometimes they do, sometimes they don't. Sometimes an endpoint ends with com. At other times, it does not. Peter DeSantis said, now, every service you operate needs to have at least one virtual IP or VIP or endpoint. And as I alluded to earlier, it should probably have more than one. He later tells us, at Amazon, we got the service bug early. I think we were doing microservices before we had a name for them. To give you some perspective, 10 years ago, we had 6,000 virtual IPs or endpoints at Amazon. Now, how many do you think we have today? 600,000. This is DeSantis speaking in 2017. So you can see he's equivocating virtual IP and endpoint. He's saying 10 years ago we had 6,000 virtual IPs or endpoints. That's the end of our endpoint discussion. The inspection VPC. Let's now continue with the article by Shakil Ahmad and Evgeny Vaganov on the AWS Network Firewall. We were told that we must route traffic symmetrically to the AWS Network Firewall endpoint. What does it mean to route traffic symmetrically? How do you route traffic in a manner that means you're doing it symmetrically? It means that traffic should leave the same way it enters, and it should enter the same way that it left. This firewall endpoint is similar to private link VPC interface endpoints. The key difference is that it can be a route table target. AWS Network Firewall endpoint is deployed into a dedicated subnet of a VPC. We call this subnet an AWS Network Firewall subnet, or simply a firewall subnet. Depending on the use case and the deployment model, the firewall subnet could be either public or private. For high availability and multi-AZ deployments, Allocate a subnet per availability zone. As a best practice, do not use AWS Network Firewall subnet to deploy any other services, since AWS Network Firewall is not able to inspect traffic from sources or destinations within the firewall subnet. Recall that there was a period of 2 years between 2019 and 2021 when the Internet Gateway and VP Gateway were able to send traffic to specific subnets, but subnets themselves were not able to. The AWS Network Load Balancer, that first emerged in 2020. So it emerged when subnet route tables were not allowed to contain routes more specific than the local route. So initially we were suggested deployment models for the AWS Network Firewall, which were on a grand scale. These were models for architectures consisting of multiple VPCs. There was none of this filtering traffic as it passed from one subnet to another within a VPC. That idea, that only came in 2021. Two fundamental models were proposed by Shakil and Vaganov in 2020 in their blog post. On one model, every VPC in your architecture has its own firewall subnet. This is the distributed model, because firewall endpoints are distributed across your VPCs. Right? Every VPC has its own. On a second model, we requisition a single VPC for inspecting traffic, and that's known as the centralized model. These are the two deployment models, the distributed model and the centralized model. The distributed model even allows for the firewall endpoints within each VPC to be made highly available. You can deploy multiple firewall subnets in their own AZs. Look at the image below, which is homed in on one VPC. So let's break down this image. So you can see the green box is the VPC. We've got 3 physical availability zones within this. Each AZ has its own firewall subnet. Okay, you can see 1, 2, 3. There's one workload in a subnet in each AZ, each of the 3 AZs. If we look at the route table for the workload subnet, we've got a local route, a local entry, and a catch-all route, all zeros for the VPC endpoint ID for that availability zone for AZA. Okay, here VPC endpoint ID for AZB, VPC endpoint ID for AZC. We've got an internet gateway in the wall of the VPC. The internet gateway has a route table. It's got a local route, but it's got these more specific routes, /24, they're more specific than /16, and all of the 3 /24 routes have as a tangible target the VPC endpoint ID for those firewall endpoints. So 3 routes. This can go to either the endpoint in AZA, the endpoint in AZB, the endpoint in AZC. Okay. So we've said the distributed model even allows for the firewall endpoints within each VPC to be made highly available. You can deploy multiple firewall subnets in their own AZs. But this isn't shown here because here we can only see one VPC, so we can't be looking at the distributed model here, can we? Well, we could be looking at one part of the distributed model. It could be that beyond this diagram there are other VPCs, and this diagram is in fact demonstrating high availability because we don't just have one firewall subnet, but 3 firewall subnets. And they're in separate availability zones, which is contributing to increased availability. If AZC goes down, we still have AZA and AZB, and you'll notice that the Internet Gateway has a route to all three of them, so it really can independently depend on each of the three firewall endpoints. So it is demonstrating high availability. Okay, you can deploy multiple firewall subnets in their own availability zones, and that's what we have. It's true that in this diagram we only have one firewall subnet per availability zone, and there's nothing to stop you putting multiple subnets in one AZ or multiple firewall subnets in one AZ, but I'm not sure how useful that would be. But anyhow, here we only have one firewall subnet in each AZ. Notice how we're using all zeros /0 and choosing the endpoint for the target. We are used to seeing 0000/0 with a target of Internet Gateway. That's what we're habituated to seeing. Well, we are using a catch-all route to send traffic to the endpoint. Let's take a look again. So, this route table here at the top of the diagram on the left-hand side, not the route table on the right-hand side, the one on the left at the top of the diagram is the route table for the firewall subnets. And you'll see they have 00/0, but the tangible target, the thing to aim for, is the Internet Gateway ID. Okay, that's a familiar idea. That's fine. But I think the point we were trying to make is if we look at the workload is in its own subnet for each AZ. That has all zeros, but it's not the Internet Gateway ID. It's the endpoint for the firewall endpoint, right? VPC endpoint ID for AZA. So that's what we have with all zeros. So don't think that just because the destination is all zeros, the target has to be an Internet Gateway. There's no necessary connection there. Here we want our workloads to have destination all zeros and the target be the endpoint ID for availability zone A. Okay. We are using a catch-all route to send traffic to the endpoint. We're saying that traffic which wants to leave the VPC must first go to the endpoint. Again, in 2020, so in other words, it's not an accident that 0000/0 is associated with Internet Gateways usually. I've said it's not a necessary connection, but it is important that it's the usual connection. Because we are saying, well, okay, if you're going to 0000, you should first go to the endpoint, the firewall endpoint, right? So that's why we're actually taking that all zeros, which is usually with the Internet Gateway, and making the target be actually the firewall endpoint first. And then once it gets to the firewall subnet, which contains the firewall endpoint, then we can say, okay, now we can have all zeros and go to the target actually be the Internet Gateway. Now, in 2020, we did not have the ability to put the CEDAR of a specific subnet. But in 2021, we started to see things like this. Okay, let's break this down. So we have, again, multiple AZs, one AZ on the left, one AZ on the right. That's the dotted rectangle with a blue colour. If we look at AZA, we've got an ALB, an application load balancer in a public subnet. It's got a route going to 10.0.0.0/16, which is the VPC CEDAR if you look. And the target is the VPC endpoint ID for availability zone A. There's another route which is all zeros going to the Internet Gateway. So that's the public subnet. It's got the application load balancer in it, so it goes up to here, but it also has a catch-all route going to the firewall endpoint. If we look at this private subnet, which has the application inside it, we've got the sort of seeder of the VPC with a target as the endpoint ID, the VPC endpoint ID for availability zone A. But then we've got 10.0.10.0/24, and this is more specific than the VPC itself. And this is actually pointing to the endpoint ID in availability zone B. Again, I'll say that again. So this private subnet here is actually having a route, in possession of a route to an endpoint, the VPC endpoint in availability zone B, which is over here. So it's pointing to this firewall. If we look at the route table for this subnet at the bottom, which has the database in it, again we've got the VPC seeder featuring as one of the rules, but we also have 10.0.11.0/24. Again, because it's /24, it's alarm bells to me because it's more specific than the /16. So what's 10.0.11.0? Where is that? Well, I can see that that's over here. That's the private subnet in availability zone B. See, this says 10.0.11.0. So both of these blue subnets on the left here seem to have routes which are going to something over here. This top subnet has a route going to the public subnet over here, 10.0.10.0. Yeah. Look at the route table, 10.0.10.0/24. So it's going to over here because this public subnet in AZB is 10.0.10.0. And even this database subnet at the bottom here has a route going to the private subnet on the right here. So the application goes to the public subnet, the database goes to the application here, 10.0.11.0. A lot to take in with these diagrams, so we're taking it gradually. Now I want to step back and just look at the arrows. So we have 1 going from the internet gateway to the application load balancer, 2 from the application load balancer to the firewall endpoint. Now where do we go? Do we go to the data layer? Because we've been to the top layer. Usually we think of applications as having a top, middle and bottom layer. Web, application, and then the data at the bottom. So we come in, we go to the LB, then we go to the firewall endpoint. But actually you can see number 3, this circle crosses and goes all the way over to the other AZB. So we've got this cross availability zone movement. It is going to the second layer down though, it's going to the application layer in the middle. It's just strange because it's gone to a different AZ in order to do that. And then this circle says 4. We're going from, let's see where it goes. We go from the application in this subnet back over into AZA to the firewall endpoint. So we go 3, 4 into AZB, welcome to AZB, and then number 4 back out of AZB into availability zone A. 3 and 4. And then it says 5 is back to the application load balancer. So and then 6 is from the application load balancer back to the internet, and that's a complete route for the white circles. So in to the ALB, to the endpoint, we then just bob our head into the application in AZB, back out, firewall, ALB, out to the internet. The blue circles represent a different route. Number 1 is over here. We start at the application in AZB. We go out to the firewall endpoint. So this is a completely different example because now the application is initiating. It's not coming in from the internet. We're sending out a request from the application layer. It goes into its firewall endpoint. Look at the circle number 2. We then go from the firewall endpoint to the database layer, the private subnet here. Number 3, back to the firewall endpoint. So we're literally just popping into the database, back out into the firewall endpoint. Number 4 is back to the application, and that's the blue circles complete. So the white circles represent a request initiating at the internet and coming in to the application layer, and the blue circles represent an initiation from the application layer. What's interesting is that sometimes we cross the availability zones, but more importantly, sometimes we don't. Okay, so we don't cross the availability zones in order to go through the firewall endpoint. So notice that when the traffic comes into the internet gateway and goes to the ALB, we immediately go to the local firewall endpoint. Remember the principle of local inspection, because we could say, let's go to the firewall endpoint in availability zone B, but we don't. We choose to use the local firewall endpoint, the one that is in the AZ that we're already in. And similarly, when this application here in this 10.0.11.0 subnet, the application layer subnet, when it initiates a request, we go to the firewall endpoint which is in the availability zone that we're in. We keep the traffic within availability zone B, because this private subnet with the application resources in, the code on the EC2 instances or whatever, we're already in availability zone B, so we use the firewall endpoint here. Now, of course, once we leave the firewall endpoint, once it's passed through that and undergone its inspection, then we can go and use the database in another availability zone, and we do. We have the traffic go to this DB subnet, database subnet, which is in availability zone A. Then we go back to use the firewall endpoint in availability zone B. Perhaps that's interesting. You might say, well, why not pass it through this firewall subnet here in availability zone A? After all, we're already in availability zone A, so why not use this one in availability zone A? So perhaps there is in the background some principle, such as try to just use one firewall endpoint for a particular traffic. In fact, this may be the symmetry principle. We want the two legs to be the same. We can talk about the inbound leg and the outbound leg. So the application here, number one, it initiates a request. It needs to get something from the database. Well, that's the outbound leg, 1 and 2. And then the inbound leg is 3 and 4. And so we're saying we want those to be the same. We want the outbound leg to just be the reverse of the inbound leg. And if we said that the traffic goes into this firewall endpoint in availability zone B, then it goes to the database, then it goes and uses availability zone A, well, then we wouldn't have that symmetry. And that's just a principle that we're adopting. Ensure symmetry. Okay, let's leave that there for now.